Okay, let's talk about something called supervised learning. Imagine you want to teach a computer to recognize different objects in pictures, like a tiger. You show it a bunch of pictures with objects and their names, so it knows what each object looks like. This is like giving a computer a quiz, but you're also providing the correct answers. We call them labels. You can teach the computer about other things too, like how much you liked a recipe. You would give it recipe and your rating, like yummy or not so good. After showing a lots of recipes and your ratings, the computer will start to guess how much you like a new recipe you give it. Your ratings are the labels. The more example you give the computer, like more pictures of tigers or more recipes, the better it will get at guessing the right answers. Once the computer is good enough at this, we say it's been trained. But remember, the computer doesn't really know what a tiger looks like or how food tastes. It's just using examples you gave it to match new things to the right answer. Based on patterns it learned from the examples. Some cool pictures on the internet that a computer had never seen before. This computer called the classifier was taught to recognize 1,000 different things. When it looks at a picture, it tells us the top 5 things it thinks the picture could be and how sure it's about each guess. So in one picture there's a bunch of bananas, as you see. We would like the computer to say bunch of bananas, but it was never told that. It only knows the word banana, so that's what it tells us. It's kind of like how we can only name things with the words we know, right? In another example, the computer is super sure that one picture is a banana. In a different picture, it's 60% sure it's an ear, but 40% sure it's corn. It's helpful to know how confident the computer is. So if it's not very sure, we can try a different method or even ask a human for help. Imagine you have a bunch of stuff without any labels, and you need to find a way to understand how they are connected. That's where unsupervised learning comes in. It's like having a smart computer detective that looks for patterns and relationships in things without any hints or labels. Let's say you're digging a hole to build a new house and you find a bunch of old clay pots and vases. You call your archaeologist friend to help you figure out where they came from. But she doesn't know either, so she decides to use a cool computer trick to solve the mystery. She takes the pictures of the markings on the pots and lets a machine learning algorithm group them together in a way that makes sense. This trick is called clustering, and the computer program doing it is called a clustering algorithm. It helps us organize data into groups, like putting puzzle pieces together. Unsupervised learning is just for solving ancient mysteries, though it can also help us clean up messy data, like removing spots from a photo taking with a cell phone camera. Or it can help us make a file smaller without losing important information, like when we turn songs and pictures into MP3 and JPG files to save space. Imagine you want to teach a computer to do something like play a complicated game or make music. Sometimes we don't even know the best way to do it ourselves. There might not be one perfect answer, but some options could be better than others. It would be cool if we could teach a computer to find the best steps by trying different approaches and ranking them like probably good or better than the last one. Let's say we need to manage elevators in a new office building. We have to decide where the elevators should wait when they're not in use and which one should respond when someone calls for it. We want to make sure people don't wait too long for the elevator. But how do we do that? The best solution depends on when and where people want to go. In the morning, everyone's coming to work, so maybe we should keep empty elevators on the first floor. At lunchtime, people might want to go outside, so we should have elevators near the top floors, ready to take them down. If it's raining, they might want to go to the top floor cafeteria instead. What's the best plan for every day and every hour? There's probably no single perfect plan, so the computer can just give us one. Instead, we can try different ideas and choose the one that works best. The computer can create a plan or change an existing one, and we can see how well it works by checking the average wait time for riders. After testing many plans, we can pick the one with the best score. As time goes on and patterns change, we can keep trying new ideas and always use the best plan. This is called a reinforcement learning. RL is a technique used in super smart game playing programs that have beaten humans at games like Go and even online games like StarCraft.